So today I'm doing standard 2.1. I'm doing problem 218, and so it gives you a spin 1 particle is prepared in this state. So a spin 1 particle can have 3 different spins. It can have 1, 0, or negative 1. Part A asks to find the spin components, or the possible spin results of the S sub z. And so, since we have 3 inputs, there's 3 possible outputs for a spin 1. You can either have a positive 1 spin, a negative 1 spin, or a 0 spin. So next it asks to find the probability of each spin. So first I'm finding the probability of getting a +1 as the output. And so it's written like this, where phi is the input, 1 is the output, and then the probability is that squared. And so expanded out, it becomes this. Now, if you have, so we want a +1 output. The only way to get a +1 output is to have a +1 input. So if the input is 0, like here, we can't get a 0, or we can't get a 1 output. So therefore, the only component that matters is this one. So these two are going to be 0, and so it becomes 1 over the square root of 14 squared. And that just becomes 1 over 14. And then for the negative 1 as an output, we get the same thing. So the only way to get a negative 1 output is with a negative 1 input. So this, the +1 input and the 0 input both go to 0. And so it becomes I times 2 over square root of 14 squared, and then that becomes 4 over 14. Again, same thing with 0 as the output. The 1 input and the negative 1 input both become 0. So the only term that's left is negative 3 over square root of 14 squared, and so the probability of finding 0, of getting a 0 spin, is 9 over 14. And we can check that it's correct because these values should add up to 1. And so, because the probability, the totals of the probability should be 1. So 1 over 14 plus 4 over 14 is 5 over 14. And then 5 over 14 plus 9 over 14 is indeed 1. So therefore, we know these are probably the right probabilities. So next, for part B, it wants us to find the different spin components in S sub x after the S sub z negative 1 spin from part A. So in other words, it's going to go through the first filter, and then the ones that are passing through the negative 1 in part A, we want to find the probabilities of the S sub x outputs. And so again, we're going to have 3 different probabilities. The output's either going to be 1, 0, or negative 1. And so the eigenstates of S sub x in terms of S sub z basis is given in the book as equation 2.113, and it's written out here. And so we're going to do a similar process as in part A. So the probability of getting a +1 spin for x is written as this right here. So our input is negative 1, and our output will be 1. And then, so expanded out, it becomes this. And so we get this first part from up here. Up here, this is written as a ket, and we can turn this ket into this bra by finding the adjoint. And it's relatively simple since there's no eyes. And then, again, we do the same thing as before. If we have a -1 as the input, we're only going to get a -1 output. The others go to 0. So this just becomes 1/2 squared. And that becomes 1/4. Do the same thing. We find the adjoint from this. And then, again, same thing. It becomes 1/2 squared. Becomes 1/4. For the probability of finding 0 in the x, we turn the ket into a bra, and the first term gets canceled, and so we're left with -1 over square root of 2. That squared is just 1/2. We check our answer, so 1/4 plus 1/4 plus 1/2 is indeed 1. And so part C just asked to draw a diagram. So here is our input state, which is that first function we were given. And I have the probabilities written out. So it first passes through the z. The probability of getting a plus is 1/14. Getting a 0 is 9/14. Getting a negative h of z is 1/4. And once it passes through this negative h sub z, it goes into an x filter, and we have our probabilities again. So finding a plus h of x is 1/4, 0 is 1/2, and negative h sub z is 1/4.